Hello everyone. Today we are going to discuss about ECC 3003 Engineering Math 3 Assignment 1. Our group is group 5 and below are the group member of our group. In this assignment we are given two questions which need us to solve using Fourier transform. For the first question, the ft is a piecewise function which have two different functions that from boundary negative t to 0 is a over t bracket small t plus a, and for the boundary 0 to t, ft is negative a over t bracket small t plus a. Firstly, we have to sketch a graph for the piecewise function, and by looking at the function we will know that it follows the y equals to mx plus c straight line equation. So for boundary negative t to 0, when t equals to 0, ft will be a, and when ft is equals to 0, t will be negative bit t. So we can draw a straight line at these 2 points, so that uh, at these 2 points it will be a straight line. So for boundary 0 to t, when ft is equals to 0, t is equals to big T, and when t is equals to 0, small t is equals to 0, ft will equal to a. So we can plot another line using these 2 points. So basically this is the graph for the piecewise function ft. As for the Fourier transform, we will note that the general equation is for Fourier transform f j omega is the integral from negative infinity to infinity f t times exponential negative j omega t dt. So we can we have to identify each ft and the boundary for each. So uh, so start from negative t to 0. The ft is a over t plus bracket a plus a, s, and for 0 from 0 to t, the ft is from negative a over t bracket t plus a. So after we expand the equation, we will get a line like this. So for the integration t exponential negative j omega t dt, we can solve the integration by parts, by uv minus integral v du. So this is basically the integration by part for the integral t exponential minus j omega t dt. So we will, by using the LPT, that is long polynomial exponential and trigonometry. So we can assume that u is equals to t, and integral v is e exponential negative j omega t dt. So we have to differentiate du over dt, which will be equal to 1, and du will equal to dt, and v integral of v will be exponential negative j omega t over negative j omega. So I've substitute the respective terms into the uv minus integral v du. And solve it by one, we will get this equation. That is t over negative j omega times exponential j omega t plus 1 over omega square times exponential minus j omega t. So after that, we can substitute in the we can put in the integral and substitute the respective value. We will get a line like this. So until here, we can now we can now so now we can rearrange the symbol and expand the constant into the the equations so that we will get a line like this. Until here, we can now cancel out some of the similar terms, right? A over j omega times exponential j omega t can be cancelled out by with this, and a over negative a over j omega can be cancelled with this, and a over j omega times exponential negative j omega t can be cancelled with this, so that we left only 4 terms into here. Then we can rearrange and we will get a new line like this. After adding together for a over bit t omega square and summarize out the summarize the a over t omega square, we will get like this. So bear in mind that cos x is equal to exponential jx plus exponential negative jx over 2. So we have to add a 2 inside the exponential j omega t plus exponential negative j omega t, so that we will get equation like this, and we can now solve it by using the double angle formula. That is cos 2 theta equals to 1 minus 2 sine square theta. When we only have cos theta, we will have 1 minus 2 sine square theta over 2. So we can now substitute in the cos theta into it, and we will get a new line like this. So we can expand the 2a over t omega square into the 1 minus 2 sine square omega t over 2. After that, we can cancel the 2a over t omega square, so that we only left 4a over t omega square sine square omega t over 2. So for the sine x is equal to sine x over x. So we have to have the same value of x. So we just take it down and times the same value, so that we will have the sine c. So the final we can cancel out the the 4 and the omega t, so that we will have only left at sine c squared omega t over 2. Now that we will proceed to the Matlab for this question. For Matlab of this question, we will have this. This is the coding for the Matlab of f Fourier transform of at sine c squared omega t over 2. So the symbol W is the declaration of omega for the double, and omega we will set it as from negative 3 pi to 3 pi. The pi over 360 is to stabilize the graph so that we can get a smooth graph. So we will have the constant a equals to 1 and t equals to 1, so that it will not interrupt the graph. The equation f equals to a t times sine c squared omega t over 2 is shown by here. So the amplitude of the coding can be shown by ABSF, and to plot the graph we have the coding is like plot bracket omega comma amplitude sp, and this is for the title for the x-axis and the y-axis. So for the graph it will be like this. For the amplitude graph it will be like this, and for the phase spectrum graph the coding is angle bracket f, and the coding for plotting the graph is plot w comma phase spectrum for the, and the back is for the title, and the x label and y label is axis. So the graph will be like this. We will get a straight line graph. So that's all for question 1, and we will proceed to question 2.